Why does magnetic interference affect RC drone calibration? Imagine trying to find your way in a new city with a faulty compass. That's what magnetic interference can do to your drone. When you calibrate an RC drone, especially a quadcopter, it relies heavily on a digital compass called a magnetometer. This tiny sensor helps the drone figure out which way is north so it can navigate accurately. If magnetic interference is present, it distorts the readings from this compass. That means the drone might think it's facing a different direction than it actually is. This can cause it to drift off course or even crash during flight. Magnetic interference comes from sources like the drone's own motors, batteries, or metal parts inside the frame. External objects like cars, power lines, or large metal structures nearby can also create magnetic fields that mess with the compass. During calibration, the drone rotates to measure the magnetic field from different angles. If there is interference, the data it records becomes distorted. This distorted data is then used to set the drone's navigation system. When the drone flies, it uses this faulty information, leading to unstable or unpredictable behavior. To avoid this, you should keep the compass module as far away as possible from the drone's motors, batteries, and metal parts. Calibrate the drone in an open space, away from large metal objects or electronic devices that emit electromagnetic fields. If your drone's compass becomes magnetized, using a demagnetizing tool can help remove the magnetic buildup. Always follow the manufacturer's calibration instructions carefully and keep your firmware updated. If you notice persistent interference, try physically relocating the compass sensor or shielding it with a non-magnetic cover. Understanding magnetic interference is key for RC drone pilots because it directly impacts navigation and flight safety. Proper calibration free from magnetic distortion ensures your drone can use GPS accurately, hover steadily, and respond correctly to your controls. This is especially important for tasks like aerial photography or precision mapping, where accuracy matters most. So, always check your surroundings before calibrating and make sure your compass is in a safe, interference-free spot.